Hey guys, welcome back to AlgoYogi. Today we'll be starting a new series, which is Graph. We just wrapped up our stack series. So as you can see, we have completed trees, binary search, 2 pointers, linked list, and stack. Now we're starting Graph, and then we'll be moving on to dynamic programming. And by the way, array string hashing, I've already solved a lot of problems there, but I've just not marked them correct because I was solving them in Hindi. So I'll be posting, I might be doing it at the end because that's one of the simplest series, I would say. So let's get started with the graph, our very first problem. So there are only 3 easy problems and rest everything would be medium. And I might be adding like little more problems. So right now it might be around, I would say like 30 problems, but I'll add definitely make it up to 50 definitely. And once you do 50 problems of graph, and these are the standard problem that have been asked a lot of times in the coding interviews. I've selected them very carefully. So let's what I was saying is, like, if you complete all these problems, then I guess you can tackle any other graph problem. So let's get started with our very first problem, verifying an alien dictionary. It might not come off as a very graph problem, because graph problem has like these nodes, and these nodes are basically have edges connecting these nodes. But in this case, you'll realize that like that's not really the case once we go through the problem. But I'll tell you one thing, that this problem definitely qualifies for the graph because it maintains this relative order of these words that we are going to compare. Let's compare these words. So in an alien language, surprisingly, they also have English lowercase letters. Of course, English is a global language or solar language, but possibly in a different order, right? The order of the alphabet is some permutation of lowercase letters, right? So given a sequence of words written in alien language, and the order is given to us because their order is different, right? So return true if and only if given words will be given an array of these words. We need to return true if the given words order is basically sorted lexicographically in the alien language. So what does that mean? If let's say if in our dictionary, if in our I would say alphabets, how would you compare 2 words basically? So to compare the let's say if we were comparing, given that we were doing it according to our alphabets, so we do it by comparing like word by word. So if I'm comparing these 2 words for like our alphabets A, B, C, D, E, F, G, so I will compare the very first words, right? I'll compare the very first words and check if my first word, this is my word 1, if it has its first word, which is H, does it come before the first word of second word? Oh, sorry, first letter of second word. So these are the 2 letters that I'm comparing in the beginning, and I can tell that H comes before L, right? H comes before L, so this would be true. And you don't care what comes next. It's the first different word that you compare. So same way we will be doing it for the alien dictionary, but we will be doing it as per the order that's given to us. They use the same alphabets, but they do not use the same order. So our ABCD order could be there could be LMFG ABC, something like that. Okay, so how are we going to compare it? So I think in this way, like, it might be the brute force approach, but also I guess the most efficient, because it's straightforward approach. It's just we go through word by word, and that too we are comparing just 2 words at a time. So if let's say our list of word is, let's say, word 1, word 2, word 3, and word 4. This is my list that I need to basically check that these words are sorted lexicographically. So that means that if you compare all these words, it should be like word 1 is smaller than word 2, word 2 is smaller than word 3, word 3 is smaller than word 4, and so on. So in order to compare word 1, I'll be comparing it to word 2. If I can prove this right, then word 1 will be the smallest, because I will then compare word 1 and word 2 and word 3, and then word 3 and word 4. So I will be comparing them in pair. All right. So in order to compare these 2 words, I will go through all their letters, and it could be I can do that by basically using a for loop. But before that, how am I actually comparing? I'm comparing based on the index order of these letters or characters. So it will be 0, 1, 2, 3. So let's take our first example. So these are just 2 words that we are comparing, but later there will be like tons of words that we will be comparing. So for our first one, if you see, in order to compare my word 1 and word 2, I will start my, let's say if I will start my ith index at 0. So this is what I'm comparing, and L is what I'm comparing to, and this is the order that I should see all of the characters. So I see H. What is the if you compare H with L, should it appear before or after in our order? So as you can see, H is the first word in our alien dictionary. So that means H is the smallest. So it's in the right order. And once you compare this, you don't care about all of the remaining letters, because you only compare the first differing character. So for example, let's say I was comparing, let's say, apple. So apple is my first word, and apricot is my second word. So in this case, you can see that these two are same. These two are same. These two are also same. So these can't be used as to compare this relative order lexicographically, graphical order of these two words. But when you see the third letter, which is in first it's P and in second it's R, you can see these two are different. These two are different. P and R are different. So what we will be doing is you're going to find out the index of P in our basically order that's given to us, and let's say it's something like 18 or something, and then it might be not the exact order, but let's say it's 18, and then there is R will be 19, right? It's right here next to P. So you can tell that 18 is less than 19, so that means they are in right order. These two are in right order, aren't they? So that means this was the first differing character that you found, that apple had it smaller than apricot. So this is the right order according to this alien dictionary. All right, so this is how you'll be doing if few characters in 2 words are same, but there will be at least some differing character that has the same those are different characters. That's where you'll decide using the index of these orders. So we'll be creating like a dictionary. We'll be creating a dictionary mapping all these words with their index, so that it's easy for us to access the index in order to compare for the differing letters. All right, so and there is one more thing that I need to tell is, what if you have these 2 words? Let's say you have these 2 words. I would say HELL, or I think I would rather choose because it's bad, right? So I would rather choose high, and this one will be HILLO. Oh my god, this is okay. This is he and this is hello. All right, so if you see right here, what if I switch the order? So what if I switch the order? So I was just preparing this hello and he. Okay, these two are comparing. So first thing is first letter is H, which is same, so we go to next. Is same, so we go to next. Now here you don't have a letter here to compare, right? So that means this should have been the first word in order it to be a valid lexicographically sorted order, but it is not. So we'll compare that scenario also, where words that are seen in one of the words, like let's say if you were iterating word 1 and you already reach the end of the word 2, but word 1 still remains unvisited, all the characters are not visited, that means you will basically return false in that case too. Okay, so I guess this will be of, let's say there are n number of words, and max length of one of the words is n, so it will be m into n time complexity solution. Okay, worst case. Otherwise, somewhere like it's a average solution, then we would somewhere return will break out, right? So I'm gonna switch the view to editor, and let's write down our solution. So first thing first, let's create our alien dictionary order. So that will be, I'll say the character will match with the index in I, C, in Inu, enumerate. What are we enumerating? We are enumerating the order. Yeah. Okay, so that's our order with the character matching with its index. So let's compare for I in range, and we'll be going to length all the words. Let's not go all the words, just -1, because we are comparing. So word 1 and word 2, these are two words that we'll be comparing at a time, and word 1 comes from words at ith index, and word 2 would be words at the i+1 index. That's why I'm going until 1 less than the last index, okay, last valid index. So these are the two words that I'm going to compare. So I will be, let's not decide like which one is smaller, which one is bigger, but just I want to see like every single letter in my word 1, if they are like all same, or the first differing letter is smaller than, has a smaller index than the word 2. So let's say for j in range, length of word 1, I want to check if let's say if let's get the letters here. So I want to get the letter W1 L, or should we call it C? Yeah, I'm gonna call it char W1. That will come from word 1 J, and char W2, that will come from word 2 J. But remember, this word 2 could be smaller, so I will check here if length, yeah, I don't have to do it like this. I could just say if j is equals to, because j is increasing in like incremental order, so whenever j becomes equal to length word 2, if it ever reaches that index, because length 1 is greater, then we just return false. This is awesome, okay? Otherwise we get these two words, and then we say if they are different. So char word 1 is not equals to char W2. Okay, if these are not same, then we are going to compare the relative order of these characters. So what will be the relative order? Tell me, what will be the relative order? It will be basically we get the alien order. We're going to check if alien order of char W1, this should be smaller, but how about if it is greater? If it is greater than the order of my char W2. If this is the case, then I will return false. Otherwise they were basically in the right order, but I don't want to compare like the remaining words. So because you only compare the first differing character, so in this case I can just, else I can just break from here. So I'm breaking out from this first loop. So whenever you're writing a break, that means it's or continue. Like if you write a continue, it's want to continue the next character that we are iterating. But if you're writing break, it will go to the first loop, is parent loop, and that's where it will break out. Then it will again start comparing next two words. Okay, so that's why we need a break here. Otherwise we will be done comparing all the words, and we will just return true otherwise, right? Because we have compared all the words and they appear in the right alien order of these alphabets. So I'm going to zoom out before we run our code. I think this is not in, this is 4 when we are basically going over all the I and C. So for I is the index, C is the character in enumerate order. I think now we're good to test. Okay, yeah, this is accepted. Let's submit. Yeah, it's a pretty efficient solution. So let's write down the time complexity. Time complexity is going to be big of n into m, where n is the number of words and m is the max word length. Okay, and space complexity is going to be big of 26, or you can say which becomes big of 1 constant. All right, then let's go to AlgoYogi, mark our problem solved. And I see you'll realize that I have moved this status to this side, so I could, while recording the video, like that marking this status is not hidden anymore. But now it's the difficulty level that's hidden, so I'll move this to little, to the left. All right, see you guys in the next problem. Bye bye.